What is up, YouTube? Adam here. Today we're going to be going over a programming challenge in Python. Specifically, we're going to go over an easy programming question that you might encounter during an interview that involves arrays. So arrays are great for storing things, and Python has many built-in features that make our lives a lot easier when it comes to arrays. That being said, this isn't an in-depth overview of those features. There's already tons of great information available online, and I advise you to check out the Python website for more information. Okay, so let's get started. I'm going to create a script.py file, and then we'll throw in a main function. Now, from main, we will print the results of our function calls to standard out. Let's do a little test. Hello world. Okay, so now the challenge. Implement an algorithm that determines if an array has all unique values. So let's write our function signature, and we'll just call our function isUnique. And it takes a single argument, the array in which we are interested in evaluating. So the naive solution for this challenge might go something like this. For each item in the array, continue forward in the array, looking for another item with the same value. If that same value is encountered, we return false. Continue with the next item in the array until each value has been checked. So what does this solution look like programmatically? A great way to start out functions that only check a condition is to return the value true or false by default. And if that condition is not met, preemptively return the opposite. You'll see what I mean. We'll just start by returning true by default. That is to say, each value in the array is unique until proven otherwise. We could then say, for item in array, create a temporary variable called current to store the current item being evaluated. So now we need to compare the current value to the rest of the values in the array. But we don't want to start at the beginning because we would most certainly run into the value again. So how do we pick up iteration after the current value? A possible solution, not the best however, would be to use Python's built-in index method. Index takes a value and then returns the index of which that value occurs first. Combined with array slicing, we could pick up where we left off in another for loop. If the item is encountered again, we will preemptively return false. This solution has a horrible runtime because we're going through each value, then finding that value's location again, and then by going through each value until it is encountered, we're repeating the iteration to compare the item against our placeholder. So how could we write a better version? Well, an immediate improvement would be to use Python's built-in function enumerate. Enumerate not only supplies the value of the current iteration, but the index as well. So making appropriate changes would look something like this. So now we've eliminated an entire lookup operation, and the algorithm more or less reflects the solution we verbally produced. There are a couple of small changes that we could make, but in all honesty, we don't even need to iterate through the array more than once. Here's what I mean. Instead of looping a second time, we could just count how many times each item occurs. If the count of occurrences is greater than 1, then we know the array is not all unique, and we can preemptively return false. Here's what that would look like programmatically. We'll use a Python dictionary to store the count for each item. So we will grab the current count for each item, and if it doesn't exist yet, we'll initialize it to 0. Finally, adding 1 to the count. So now that we've counted this item, we can check it. Is the count for this item greater than 1? If so, we'll preemptively return false. This small counter routine is applicable across many programming challenges, and it's a handy tool to keep in your back pocket. I guarantee you'll see it again in some form or another.